If the radicand of a square root is not a perfect square, then it is considered an irrational number. Example, square root of 1. The radicand is 1, and 1 is a perfect square. So square root of 1 is equal to 1. Therefore, square root of 1 is a rational number. Next, square root of 2. The radicand 2 is not a perfect square. Therefore, square root of 2 is an example of irrational number. How about square root of 3? The radicand of the square root of 3 is 3, and 3 is not a perfect square. Therefore, square root of 3 is an irrational number. How about square root of 4? Square root of 4 is a perfect square, and that is 2. Therefore, square root of 4 is a rational number. Last, square root of 5. Square root of 5 is an example of irrational number because 5 is not a perfect square. Okay? Likewise, if the radicand of a cube root is not a perfect cube, then it is an irrational number. Example, so cube root of 1. The radicand 1 is a perfect cube, and that is equal to 1. Therefore, cube root of 1 is a rational number. How about cube root of 2? Cube root of 2 is an example of irrational number because the radicand 2 is not a perfect cube. How about cube root of 4? Again, the radicand 4 is not a perfect cube. Therefore, cube root of 4 is an example of irrational number. Last one, cube root of 8. 8 is a perfect cube, and that is equal to 2. Therefore, cube root of 8 is an example of a rational number. The identified irrational numbers on our examples cannot be written as a fraction because the decimal does not end, or that is non-terminating, and does not repeat a pattern, or non-repeating. In plotting an irrational number involving square root or cube root on a number line, estimate first the square root or cube root of the given irrational number, and to which two consecutive integers it lies in between. Okay, so work example. To locate and plot square root of 3 on the number line, we identify two perfect squares nearest to the radicand 3. So we have here square root of 1 and square root of 4. Square root of 3 lies between square root of 1 and square root of 4. Square root of 1 is equal to 1. Square root of 4 is equal to 2. Therefore, square root of 3 lies between 1 and 2. Since 3 or square root of 3 is closer to square root of 4 than to square root of 1, square root of 3 is closer to 2. That is the square root of 4. If you are going to plot that on a number line, so we have 1 and 2. So this is square root of 1 and this is square root of 4. So the square root of 3 lies closer to 2. Alright. Okay, so another example. So let's have square root of 6. Now we are going to identify two perfect squares nearest to the radicand 6. So what are the perfect two squares that are nearest to this number? So we list first all the perfect squares, starting with 1, square root of 4, another is square root of 9. So square root of 6 lies between 4 or square root of 4 and square root of 9. So square root of 4 is equal to 2. That is a perfect square. And square root of 9 is 3. Now we are going to insert square root of 6 here. But which is nearer or closer? Square root of 4 or square root of 9? So we have square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, and square root of 9. So square root of 6 lies between square root of 4 and square root of 9. And there is only one number here from 4 to 6, and we have here 2 spaces from square root of 6 to 9. So therefore, square root of 6 is nearer to square root of 4. Therefore, if you are going to plot that on a number line, so let's say here square root of 4, that is 2, and this point is square root of 9, and that is 3. So square root of, so this is the, let's say 2.5. So square root of 6 is nearer to 2. So we put it here, square root of 6. Alright. Okay, so work example for cube root naman. For example, so we have cube root of 7. Okay, so we are going to identify two perfect cubes nearest to the radicand 7. First, we are going to list cube root of 1, cube root of 2, cube root of 3, 4, 5, 6, 7. Okay, so cube root of 1 is equal to 1. 2 is not a perfect cube. Three is not a perfect cube. 4 again is not a perfect cube. 5, 6 is not a perfect cube, and also 7 is not a perfect cube. How about cube root of 8? Cube root of 8 is now, or 8 is a perfect cube, and that is 2. Okay, so therefore cube root of 7 lies between 1 and 2. So if you are going to plot that on a number line, so we have here 1 and 2. That is cube root of 1 and cube root of 8. And cube root of 7 is closer, very much closer to cube root of 8. Therefore, cube root of 7 lies this part. So this is a cube root of 7. Oh, sorry. That is cube root of 7. Okay. So that's all.